And good afternoon, everybody. Firstly, if you can all put on your 3D glasses for us, we're going to do the whole of our presentation in 3D. Something we've been doing for a couple of years now. Whenever we talk about 3D, we try and present everything in 3D. So my name is Mick Hocking. I'm Vice President for Sony Computer Entertainment Europe. I look after 3 game development studios in the UK, which is Liverpool Studio, London Studio and Evolution. And I'm also the director of the Worldwide Studios Stereoscopic 3D team, which is the team that looks after all 3D game development for Sony worldwide. My talk today is called 3D, a New Creative Tool for Gaming, and it's really a look across the last 2 years that we've been involved in 3D gaming, at how we've used 3D, some of the challenges we've faced, and some of the successes of 3D in computer games. Now, our story of 3D started back in 2008, actually, when myself and the 3D team were playing with 3D on our game MotorStorm Pacific Rift, and we decided to implement 3D on this game just to really see how it looked on one of the early prototype TVs. And we were really pleased with the results, and as such, we got to take this demo to CES in early 2009. And it generated quite a buzz. It was quite a great response from the consumers and press alike. And the net effect of that was that we were able to push to get 3D support on PlayStation 3 right from day one of 3D in the home. So in 2010, when 3D TVs started getting released to consumers, we were able to firmware upgrade the PlayStation 3 to natively support 3D gaming from day one. Now, at that time, there were around 50 million PlayStation 3s out there, so we instantly had a market of 50 million 3D compatible PlayStation 3s for anyone that bought a 3D TV could enjoy 3D gaming on. Now, one of the things that we were very keen to do from the start was make 3D on PlayStation 3 a seamless and friendly user experience from the start. And with that, we supported 3D over HDMI. And it was simply a case for consumers of plugging in the HDMI cable into their console and TV, and the rest would happen automatically. It also meant that PlayStation 3 knows it's connected to a 3D TV set. So this allows us to augment the menus in our games with the option to play in 3D. So all the user has to do is select that option and play the game in stereoscopic 3D. It also meant that for people with the same game that don't have a 3D TV couldn't accidentally select an option to play in 3D and see the wrong image. Something else we know is that we can read in the screen size. And this is obviously important because with people playing on different size TVs, as you scale the 3D image up and down, you're going to change the parallax and the depth in the scene. And we want the depth in our games to always be as the creator intended. So we actually adapt the depth relative to the screen size of your TV, so you get the same 3D viewing experience no matter what screen size you're viewing on. Of course, everyone enjoys 3D in a slightly different way, so we also ask all of our games to provide a depth slider, rather like a volume control, just so the user has some customization of the amount of depth in the game as well. Now, soon after we gave support for 3D games on PlayStation 3, we launched another free firmware update, which allowed the playback of 3D Blu-ray movies. And these are full 1080p and 24 Hz from the PlayStation 3. So again, there's a market of 50 million 3D Blu-ray players at that point, which is great for content providers to know that this hardware's out there and can support 3D in the very early stages of 2010. And as well as games and Blu-rays, we also provided support very early on for 3D photos with our free download Play Memories software. And again, 3D photos being one of the first touch points for some consumers to actually come to use 3D and create their own 3D content. So we've got a really nice piece of software to play back photos on PlayStation 3 as well. And to show you an example of this, we've actually got some exclusive 3D photos of Marilyn Monroe, which have been very kindly provided to us by Susan Lloyd from the Harold Lloyd estate. I can't think of a better subject matter to look at in 3D, to be honest. But so you can see here that we allow users to browse the photos very, very easily. and they can simply select a photo and get a fantastic viewing experience on their TV. And you can see just how good some of these stills look. What we can also do is we allow users to actually zoom in to the photos very carefully. The camera's going to go up in a minute. And as they do so, though, we are constantly managing the parallax in the scene, so you maintain a consistent and a comfortable 3D viewing at all times. Photos have proved so popular, we now provide native support on the top-level PS3 menu system called the Cross Media Bar. And also this year, cloud support, so you can enjoy 3D photos on any connected device, as well as the PlayStation 3. Now, we've now got around 62 million 3D-enabled PlayStation 3 consoles out there. And while it's true that PlayStation was the first console to really fully embrace 3D back in 2010, we've now seen that all major gaming platforms do now support a wide range of 3D. And this is a very positive thing for the games industry because it means, crucially, for our third-party publishing and development partners, they can now justify the investment in 3D games right the way across all the multi-format releases, right the way across all the platforms, which is much better for them. Now, we've launched something like 80 PS3 games in 3D so far since we started in 2010. I think we can have a little look at some of these now, some of the best games from the last year. So we've been really pleased with how PlayStation developers have really embraced 3D and made such great use of it in the games over the last couple of years. And we've had a great response both from our gaming fans and from the press alike. The first year was particularly impressive with the amount of PR and press coverage which we generated just from the 3D features in these games. PlayStation, and I think I would say this being from Sony, but PlayStation is still definitely the best 3D platform that you can buy at the moment. And this year we were very pleased to receive the International 3D Society's Technology Award for the PlayStation platform. But there have been various challenges of actually bringing 3D into gaming that we've seen over the last couple of years. Perhaps the overall one, and I think the most important message of all with 3D, is to maintain a very, very high level of quality. In fact, we think high quality 3D is absolutely essential, not only for the gaming industry, but for all of the 3D industry. And we really started very early on implementing high quality. We built ourselves a dedicated 3D team, which is myself, Simon, Benson, and Ian Bickerstaff, really to drag together all the 3D knowledge within Sony Computer Entertainment and make sure that all of our development studios not only can produce technically correct 3D, but also make the best creative use of 3D in our products. Now, we started off by training all of our development studios into how to produce technically correct 3D, so we did a lot of training, and then we give them a lot of examples about how to produce good 3D. But of course, if you're going to do 3D properly as a business, you have to have an infrastructure throughout your whole business. So we had to train the people who test our games, our QA departments, in how to look for 3D bugs. So they have to understand 3D as well as the development studios. And also the people who create our marketing assets and the people who market our games equally need to understand 3D to this level. And then because we're a platform holder, we also have to train our third-party developers and publishing partners, again, to produce high-quality 3D. And in all the studies that we've done with our PlayStation communities, a consistent message comes back, which is that there is great interest in 3D gaming from our communities, but they want high-quality 3D gaming. And the more high-quality 3D gaming that we give them, the more we'll get people to embrace it and follow the 3D gaming for a long time. Now, we've boiled down a lot of this knowledge into what we have as our 10 essential quality checks for all 3D games. And these quality checks are what we get every developer to adhere to on PlayStation 3, and they're also what we test the games against. All of our QA teams will be looking for these, any of these issues within 3D games on PlayStation 3. Now, Simon is going to do a talk tomorrow in which he's going to go through and show you examples of when people get these things wrong and what it looks like, and also what we recommend to people to actually fix these things when they do make mistakes in their game. So please go along to that session tomorrow. In addition to the technical side of quality, what we've found with games is often there are unique issues we have to deal with each game, which aren't perhaps technically incorrect, but certainly aren't providing us with a comfortable 3D viewing experience. So a simple example might be the UI in some games. So the UI here is the interface we've overlaid over Wipeout. So Wipeout here it's a very bright and vibrant game, very colourful and very fast moving. So in 2D, we have to have a very bold and colourful UI to sit over the top of it so the player can see, for instance, their energy bar or their lap time. When we put that game into 3D, though, you see it causes a bit of an issue. The UI is now clearly separated from the game scene because it's sitting on the plane of the screen, but we really want the user to look down the track and see where they're going. That's what this gameplay is all about. And the UI is now, it's almost distracting. It's almost making your eye focus on the plane of the screen and then look down the track and then focus back on the plane of the screen. So we found in 3D what we can do and what we need to do is pare back that UI so it's far less intrusive. And it actually produces a much nicer graphical result as well. We had a similar issue with player tags. So this is when we do multiplayer gaming. We put the name of the player over their vehicle. So again, another example from Wipeout here where we've got the online player name for each player near their ship. That works fine in 2D. We just calculate the position in screen space to draw that word. When we put that code into 3D, we had a problem though. The names are drawn in screen space, and of course now those ships in the distance are pushed into the TV, and the name and the ship no longer sit together. They're separated. So we had to make all games make sure that any 2D tags they were putting on, particularly for online games, were put at the correct position in 3D space. Like that. Now, in first-person shooters, we found a particularly subtle issue, and this was with the aiming reticule. So we've made this quite bright and bold. It's not bright green in the actual game here with Killzone, but what you can see here is the 2D version of the game, and the crosshair is in the center of the screen, and it represents where the gun is aiming at. So, of course, as the person pans their gun around the screen, that crosshair will sit over targets, and they can shoot the targets. If you put that piece of code into 3D, we found a few problems with it. Number one, the crosshair is drawn on the plane of the screen, and now the gun is pointing out into the screen about 1 meter. So your first issue is the crosshair no longer lines up with the end of the gun. The second issue was that we've created a fusion problem where the crosshair is sitting close to you on the plane of the screen, and in this case we're looking at a target that's a long way away. So, okay, we had to fix that. What we thought of first as the solution was we'd simply draw the crosshair at the point in depth of whatever it's sitting over. So in this case, we'd shove the crosshair right off into the distance and point it over this target. But then imagine what happens as you move through the scene. So if the gun's pointing at something far away, the crosshair's over there, and as it pans round, it comes close to us as it goes near a wall, and then it does this. And you get this crosshair jumping about in depth all over the place, so that just wasn't a comfortable viewing experience at all. What we ended up having to do was find a suitable midpoint between the end of the gun and whatever the gun was pointing at to draw the crosshair in 3D, so that people believed the crosshair was where the gun was going to shoot at, but it was also a comfortable experience as we move the camera around the scene. Finally, we had to be careful about our 3D objects and our 2D text overlays. So this is the game MotorStorm Pacific Rift here, and the game is finished. We've written game over as we normally do across the screen. When we put that code into 3D, we have the vehicle punching its way through the screen with a bit of negative parallax. And unfortunately, it's occupying the same space that the word game over is trying to occupy. And game over is obviously written afterwards. And again, it's causing a depth conflict, and it makes for uncomfortable viewing. So we had to make sure all teams were drawing all text overlays at discrete points in depth and not colliding them with 3D objects that may be punching through the screen at any point. Now, one difference that we have in producing 3D games to producing 3D broadcast or film is that The aim when you're producing games on a fixed platform, the PlayStation 3 obviously is a fixed platform console, is that we try and squeeze as much as we possibly can out of the system. We have a fixed processing power and we have fixed memory. So all games teams want to get the best graphical and physics effects in their games they possibly can in the 2D version there. And then when we come to do 3D, we're asking them typically to draw twice as much. But of course, the teams want the games to look as good in 3D as they do in 2D and have no visual compromises. So an awful lot of optimization has to go into making the game look as good in 3D as it does in 2D. Now, one of the simplest ways of producing 3D in games is instead of having a single camera on the left there for viewing the scene, we simply put two cameras into the scene and we draw the scene twice, what we call dual rendering. And this is what a lot of the big studios have decided to do. As we can see in this next clip, it produces really nice high-quality 3D. Now, when using dual cameras, what your rendering pipeline has to support is the ability to draw two entire scenes. And that often, because most games are written only to support a single camera in the first instance, that means re-engineering the pipeline to support that, and it can be quite a bit of work. Another technique that some teams have adopted is what we call reprojection, and this is something that we adapted from 3D computer animation. So here we have at the top left the original camera from the game, and below that is the depth buffer, which is a per pixel representation of the depth of every pixel in the scene. And what we do is, on a per pixel basis, we work out how far away a pixel is in the original image, and we offset it to synthesize a new camera in the scene. So then we get our left eye, right eye cameras. Now the big advantage with this technique is it can be added as a post-process. So you don't have to change your original rendering engine, you can add this on at the end. Now there is one major drawback with this though, and that's, as you can imagine, if you're synthesizing another eye, then anything that's close to you will cause you a problem because the synthesized camera will be able to see beyond it and there'll be a gap in your data behind it. It's the occlusion problem. Now, a few teams have looked at this and worked with it, and we have used various different blending techniques, and you can actually get rid of these artifacts quite well. And what we were quite pleased to see is when you see this in action, it looks pretty much as good as the dual rendering technique. One reason that we have to make the viewing of 3D games very, very comfortable and very high quality is that typically our games players have longer viewing sessions than a typical film or broadcast experience. They can easily be playing games for 3-4 hours or more. So when in 3D, we must make sure we don't tire the eyes out. One big advantage we've got over anyone in broadcast and film is we don't have massive camera rigs to place and set up. We can use virtual cameras and we can put them absolutely anywhere, and we can have any lens we choose and we can have them for free, which is all jolly nice. One of the issues with that, though, is, of course, if we set a scene up in a particular way and get the camera settings just right to produce nice 3D, we often let the user control the camera. And the issue is the user will put the camera anywhere in the scene they like and can produce very unwanted effects like this, which we never designed for. So what we've ended up doing is actually creating some software which will automatically adjust all the parameters of the 3D cameras to make sure at all times, in all circumstances, the 3D is both consistent and comfortable to view. So now we can allow the user to place the camera anywhere. So as we zoom into this character again now, the 3D always remains consistent and always remains comfortable. Which means with software like this, we can now let the user take the 3D camera anywhere in the scene they like. They can pull it out as far as they like, or push it in as close to objects as they want. And to them, the 3D always looks right, and it always looks good quality. Now, Ian Bickerstaff, who's a member of our 3D team, actually put this software together, and he's going to do a talk tomorrow on a sort of a deep dive into stereography, and will explain how he's achieved that and show some examples of how we do this automatic setting of the parameters. So it's a very interesting talk if you can go along tomorrow and see it. One question we often get asked with games is how much does it cost to build the 3D into one of our games? And it obviously depends on the size of the game, the genre, and the technical approach and the manpower applied to that we choose to use. One very positive thing, though, for us in the games industry is that of those 80 or so games we've released so far, on average, great quality 3D can be implemented for around 2% of the dev cost. And that figure compares very favorably with the investment we have to make with pretty much any of the other major features. So we can amaze our players with fantastic quality 3D for really quite a low investment. So a little look at the future of 3D. Obviously, we see a very bright future for 3D in gaming, and it's something we're very excited about. And there's many different areas we're going to be taking 3D in the future, which hopefully we'll be talking to you about over the next few years. One thing that's happening this year is we're launching a PlayStation 3D monitor. Now, this is a good example not only of a very, very high quality 3D monitor for the sort of second office or the bedroom, but it also has some unique technology in it which we can exploit by virtue of the fact that it supports 3D. Now, head-to-head gaming has been around since really the very first days of games, since Pong was around. And typically what we do to produce head-to-head gaming is split the screen down the middle. So player 1 sees the left-hand side of the screen, player 2 sees the right-hand side of the screen. And that's okay. I mean, the problem is that you can each see what each other's doing, and it can be a bit distracting if player 1 crashes and player 2 is trying to concentrate. So by changing the mode of the 3D TV and the 3D glasses, what we can do, my clicker would work. What we can do is have player 1 seeing a full screen, player 2 seeing a full screen, and the same screen at the same time. So we're getting full screen head-to-head gaming, but neither player can see each other's screen. And essentially what we've done is remode the glasses here so that player 1 becomes a left eye and player 2 becomes a right eye. And this is absolutely massive for gamers because they get full screen gaming again, but they can do it competitively head-to-head, and it's fantastic fun with a whole variety of games. So I'm going to show you a little example of this now. You're going to have to do this technology yourself by closing one eye. Another thing we're very excited about, and there's all sorts of technical possibilities we have with 3D in gaming, is pseudo-holographics. Now, this is simply done by having a PlayStation Eye camera sitting on top of the TV. And we're just head tracking the user. We're seeing where the user is in 3D space. And because we know where they're viewing the 3D from, we can change the rendering of the 3D to produce this pseudo-holographic effect. So here it looks like you're looking through a window onto a virtual world behind. And as you move around, you change your view of the object without us rotating it. To you, it looks like a solid object sat in space holographically. And this is really stunning when we shrink objects down and we bring them out into the room with you. But overall, the thing we're pushing for in the future is to maintain very, very high quality 3D across the PlayStation 3 platform. It's essential. We know our consumers want these games and they want high quality 3D games. And even though we're 2 years in now, we still regard it as our job to continue evangelizing and making sure technical quality is coming out on the platform, because that will give us a long-term business with 3D gaming. And perhaps one of the best examples of the quality we've achieved to date is the stunning game Uncharted 3, which has won so many awards I've lost count, but they also won the International 3D Society's award for 3D games. So let's have a little look at that before we wrap up.
It's just a little bit off the mainstream of gaming, but I was just interested to hear that the PlayStation, the My Memories feature, you're saying that a spin-off of that is that people are becoming interested in 3D photographs. Are they buying stereoscopic cameras to make use of that feature?
So are people buying stereoscopic cameras?
Cameras, yeah. You said that there was a My Memories feature.
Play Memories.
Play
Yes.
Memories,
Yeah,
sorry.
yeah.
Play Memories. So how are they, what's the status of the 3D photographs? Presumably they're buying 3D cameras, are they?
Yeah. I mean, the point we're making there was that because there's a lot of 3D cameras out there, and it's one of the first touch points for consumers, we've provided very sort of powerful 3D photograph software on the PlayStation 3 because it's a great place to view your 3D photos on the TV.
Right. Okay. Thanks very much.
Okay.
Okay, Mick, thank you very much for that presentation.
Thank you.